So in the problem set, you'll notice that there is a problem that requires a certain amount of work to get items 7 and 8, and I'm going to talk about how to do that in this particular example. Let's start by imagining that you have 1,000 people. That's often a way of starting because it doesn't really matter how many people you start with, and 1,000 is a nice round number to work with. The first thing we're going to do with those 1,000 people is divide them into people who have the disease and people who don't have the disease. And I'm going to call the people who have the disease Ds and people who don't have the disease non-Ds. I think on your assignment it says non-D exactly. Now, how do we know how many people have the disease? Well, that's given to you by your base rate. And your base rate in this case is 47%. So we know that 47% of 1,000 have the disease. 47% of 1,000 is 470. Now, how many people do not have the disease? Well, the rest of those people don't have the disease. So 1,000 minus 470 is 530. And over here I notice that I have written this 7 to look a little bit too much like a 1, so maybe I'll even do that. All right, now, what we want to do is to divide the diseased people into those who test positive and those who test negative. And we want to do the same thing for the non-diseased people. We'll divide them too into those who test positive and those who test negative. Now, of course, these people here are testing positive and they have the disease, so that's a correct answer. And these people do not have the disease and they're testing negative, so that's a correct answer. These people do not have the disease, but they're testing positive, so that's an error. And these people have the disease, but they're testing negative, so that's an error too. You'll see me sometimes when I work these problems labeling these numbers because sometimes you have to do algebra and it's convenient to do things this way. A, B, C, and D. And in some of the problems, that really helps you to have those labels there. So it's good to get into the habit of doing that. Now, how do I figure out how many people are here? Well, remember that the sensitivity tells you how many people with the disease will test positive. And we know that the sensitivity is 0.52. So 470 times the sensitivity, or 0.52, is how we find out the number of people who are going to go over here. And that number turns out to be 244.4. I am actually going to keep the point in there, even though you can't have a 0.4 of a person, just because that will help make other numbers more accurate than if we rounded. So when we round things like this, we can wind up making mistakes. It's not generally critical that you do that. So if you prefer simpler numbers, you can have simpler numbers in there. 244 would have worked just fine. Now the rest of this 470 goes here, and if you subtract 244.4 from 470, you get 225.6. Hopefully over the course of this semester, I will get better at writing like this, or I'll buy a different mouse that will help me to write more quickly and more fluently. Now, how do we get this number over here? Well, this number that we used here was the sensitivity, which tells us how to get this number. The specificity similarly tells us how to get this number. You can remember that specificity is the probability that a person who does not have the disease will correctly test negative. In our case, the specificity is 0.38. And so if you do the same thing as before, if you multiply 530 times 0.38, then you'll get the correct number down there. And I make that out to be 201.4, which again is one of those fractional numbers that we can keep for the purposes of avoiding rounding error. But if you wanted to say 201, you would be fine. And by subtraction, we can get the number that goes in blank C, 328.6. At this point, it is quite easy to calculate the positive predictive value, which is what you need for number 7. Positive predictive value, if you'll remember, is the probability that you will have the disease if you test positive. So let's start out with the first part. How many people have the disease among those who test positive? That's 244.4. Now, what's the denominator of this? All the people who test positive. Well, that's 244.4 added to the people who test positive but don't have the disease. Those are errors, of course, 328.6. Now, I know some of you like to memorize equations, and that can be useful. I personally don't, and I'm a little bit opposed to merely memorizing things if you don't understand them. But if you really want to memorize things and you get this equation set up correctly, the positive predictive value equals A over A plus C. Because the positive predictive value, remember, is the chance that you have the disease if you test positive. So all the people who test positive are down in the denominator, and of those people who actually have the disease are in the numerator. When we do the calculation, you should get a positive predictive value of 42.6%. The negative predictive value can be calculated next quite easily. And in the negative predictive value, what you're interested in is, if you test negative here and here, what is the chance that you don't have the disease? Well, that's this leg. So just as above, we did A over A plus C. In this case, we do B, actually D, pardon me, over B plus D. And I won't write out the numbers here, but you can plug them in. What you get is 47.2. All right, I hope that was helpful.